actually made it to its destination in one piece. Still, there's no doubt that simply getting Starship and super heavy flying is a major accomplishment. At almost 400 feet tall, it's like watching a 25-story building leap into the air on a column of smoke and fire. It's just nowhere near ready for a human crew. According to the most recent estimates from SpaceX, the earliest potential flight to Mars, without a crew, would be later this year. But that is around the same time SpaceX will be working to ready the Artemis HLS.
Hey folks, Papa D here, David Deliver Space. We are standing by for the SpaceX feed for the Starship launch today, IFT-3. We're expecting to be able to go live in about 9 minutes. As everything is fluid and dynamic, we'll keep you updated as the timeline potentially changes. Right now, we're looking at a T0 somewhere in the 8:30 range. But at this point, again, we will wait and hear what the timeline allows SpaceX to do. We're ready to go. Other than that, fueling will begin about 50 minutes before launch, if it hasn't begun already. And like I said, once we get an update on the timeline and we get the feed in, we will update you accordingly. Appreciate you coming by. Thanks to the subscribers. Thanks to SpaceX. We appreciate the opportunity to present the feed to our subscribers. And if you're not a subscriber, please feel free to do so. We'd love to have you be part of the family. So we'll be standing by. We'll cut to that feed as soon as it's available. Thanks again, everybody. And let's enjoy the show together.
the Artemis 3 lunar lander in 2026. But first, SpaceX has to successfully launch a Starship on at least a near-orbital flight, something its first 2 test flights in April and November of 2023 do.
The test flight, the vehicle's second, did show that the company had fixed key issues that arose during the earlier test operation in April. All 33 engines in the vehicle's lower booster stage fired, and the rocket made it through stage separation. When the booster falls away and the 6 engines of the upper stage light up to carry the vehicle to space. By contrast, the first Starship launch badly damaged the launch site. Several engines on the booster failed, fires knocked out the steering of the rocket, and the flight termination system took too long to explode. However, the second flight revealed new challenges. Soon after stage separation, the booster exploded. The upper stage Starship spacecraft continued heading toward orbit for several more minutes, reaching an altitude of more than 90 miles, but then SpaceX lost contact with it after the flight termination system detonated.
Yes, but this time, SpaceX has some changes to its mission and trajectory for IFT-3. Instead of landing off the coast of Hawaii, the planned splashdown location will be in the Indian Ocean. SpaceX is also increasing its goals while in space with 3 major milestones it wants to hit. A successful ascent and re-entry, SpaceX hopes to. This will allow future missions to carry full-size Starlink Gen 2 satellites for deployment to orbit and transfer between 2 tanks while in space. Moving cryogenic fuel between tanks skill needed for Starship's place as Artemis's lunar lander. This has never been done before in Artemis 3 development deadlines. The final new test item will be the first relight of a Raptor engine in space. This will be to perform a deorbit burn before re-entry. Space is a big deal. While you can test and simulate everything on the ground, you won't know for certain everything works until you
have been made to the launch pad and stage 0 infrastructure since the last flight. OX, liquid oxygen on the booster in less than 40 minutes and methane in 43 minutes and methane in 51 minutes. These improvements, coolers and pumps, ensure more efficient propellant loading. The launch pad itself has undergone time between flights. SpaceX has implemented 17 upgrades to address the issues that arose during the second flight. 10 of these upgrades pertain to the ship, while 7 focus on the Super Heavy booster. Booster 10 features noticeable exterior changes, such as revised grid fins that have returned to a previous design. Upgrades to the Starlink terminals aim to improve data. The common dome design on Booster 10 is now more rounded. Have been made. Software and engine control algorithm changes will enhance the booster's maneuverability after hot staging. Ship 28, on the other hand, significant upgrades compared to its predecessor. It was stacked in reverse order, reducing actuators for thrust vector control, improving engine compartment cleanliness, and reducing the risk of fire. Various changes and reinforcements have been in prevent fire, and adjustments to the oxygen vents inside the left skirt might aid in attitude control. The ship's heat shield placement, flaps,
include upgrading the rocket's fire impression system, minimizing leaks inside the rocket, and further reducing the chances of fires through the electronic TVC. Changes to the Super Heavy include making their way inside the engines. According to SpaceX, improper filtration was the most likely root cause for the booster explosion in November. An incredible team at Starbase, and Starship is a beast of a machine. We're standing on the edge of something huge, and the anticipation is incredible. Get ready, everyone, because this is going to be an awesome event. The third full-stack flight test of Starship promises exciting upgrades and With improvements to the launch pad, booster, and ship, SpaceX continues to push the boundaries of space exploration. As anticipation builds, we eagerly await the successful completion of this mission and the progress it signifies for the Starship program. Such an exciting future ahead of us, but first, let's talk a little about how we got to where we are today.
Now, Starship's test in July of 2019 with our Starhopper prototype, sort of a short version of the Starship that we see today. There's a great photo. It had a single Raptor engine, and we had it to test fly and perform low-level altitude maneuvers and about 20 meters in altitude. That was followed by the one that you've got on your screen here. This was our 150-meter altitude hop. We went up, took a little jaunt away about 100 meters.
Yeah, I love this shot. It's just so fun to see it fly. After a series of 150-meter hop tests with earlier prototypes, the Starship program saw a major breakthrough during 2020. SN8 demonstrated a first-of-its-kind controlled aerodynamic. The SN8 prototype rose through an of 12.5 kilometers or 7.8 miles and conducted there during its descent. While it didn't stick the landing, in fact, we should be able to see that unfortunately failed landing.
Unscheduled disassembly, but learned a lot of data. Now, the testing continued on to prototype serial number 2 miles up. In February of 2021, we had a nominal ascent. We belly flop maneuver, which is so much more fun to say than controlled descent, aerodynamic maneuver. Flight as well. We had a failure on one of the engines that resulted in so those flights was how much we learned just between serial numbers 8 and 9 and how quickly we were able to achieve. In addition to that, we got so much data that demonstrated control of the vehicle in that subsonic regime.
Ultimately, we won SN15 launched from Starbase, reached an altitude of about 10 kilometer maneuvers, and safely returned to the launch site. This was the first Starship prototype to fly them.
Flight. Now, having achieved those successes in our suborbital campaign, big challenges is for the upper stage when it comes to reusability and surviving the hypersonic, really high heating phase of while we're on orbit. That will enable us to have a fully reusable transportation missions, interplanetary flights, and will help humanity get to the moon.
Basically, our path of progress, basically each vehicle, and that iterative process is a core part of how we work here at SpaceX. We'd like to test early and often, publicly as well in our case. And
actually putting the vehicle through flight-like tests, even the tests on Monday, gave us an opportunity to learn more about the vehicle into today's launch attempt, and so far things are looking really good.
At this point in time, 20 minutes, or just over 20 minutes from liftoff, let's check in with John Innsbrucker for a status update. Hey, John.
Innsbrucker, Principal Integration Engineer here at SpaceX. We're currently loading propellant from the ground system into both the first and second stages. Liquid methane, next to the temperature of just over 100 Kelvin. That's about minus 200. Methane is a different fuel from Falcon 9. That booster uses RP-1 kerosene. However, our oxygen, we have to bring our own. Now, leading up to where we are right now, we had a go-no-go putting propellants onto the booster at T-minus 1 hour and 39 minutes. At T-minus 1 hour and 12 stage, you can see on your screen right there. Now, propellant loading of the Starship start, at which time we then began loading the 2 header tanks in the heavy propellant loading completes. That means we'll have all the rocket and the vehicle will be fully loaded with over 10 million pounds of propellant. T-minus 19 minutes and counting from liftoff. The weather and winds are looking good. We have been watching as the morning continues, they will increase, but that is below our limits right now. We're also looking at upping to be go. On the launch vehicle itself, the teams, the good news, they're not working any issues. However, we're not sure when it would be. It could be 24 or 48 hours after today. It'll get into the countdown. But right now, heading for a T0 at 8:28 Central, 13:20. The amount of work our team invested in today's third Starship launch. I'm very sure in our success during this testing. So, let's go.
Thank you, John. And now we want to remind the broadcast audience is already waiting for Elon to go out on trust this moment worth it. Shiva, what's so important Elon Musk is about to say? How do you think?
I've honestly no idea, but what I know is surface. That's opposed to taking off and landing on a runway like aircraft do. And that's important because there are no runways on the moon and Mars. The ship features 6 Raptor engines, 3 of which are sea level, and 3 of which are vacuum engines with an expanded nozzle, which makes them optimized to operate in the vacuum of space. The ship, at the top of the ship is featured with 4 flaps as well. This is a shot actually of the top of the booster where we can see the hot stage portion and the 4 grid fins. Now, those flaps on the ship portion help aerodynamically control the vehicle's attitude during atmospheric reentry and flight, and will enable us to do precise landings. The body of Starship is also wrapped in a heat shield that's made up of 18,000 hexagonal ceramic tiles. You can see them wrapping around the top of the nose here and here in this shot of the flaps. Now, those tiles are designed to insulate the vehicle during atmospheric entry, where the temperatures can get as high as 1,500 degrees Celsius. And one of our test objectives today is to verify how those systems perform during reentry.
Yeah, now as Shiva mentioned, there between the ship and the booster, basically the top of the booster, between those 2 stages, that's our new hot stage, critical for our new separation technique. As we talked about earlier, we are constantly learning and upgrading the vehicle after we test. Now, this is a pretty exciting first for our team, as hot staging has never before been used as part of a reusable space transportation system, let alone on a rocket with the size and power of Starship. And we're really hoping to gather data on it during this highly dynamic phase of flight. And that is, once again, assuming that we even make it that far.
Of course, let's take a closer look at what we expect hot staging to look like. Now, it occurs at about liftoff plus 2.5 minutes. At that point, the booster will shut down most of its 33 engines, leaving just 3 running. And the ship will ignite all 6 of its engines. Clamps will release, and then the ship will thrust away from the booster. Now, this is the first in-flight test of the heat shield on the top of the booster and the bottom of the ship, and of course the first in-flight test of hot staging, and we're hoping to gather a ton of data on it today.
Yeah. Now, stage separation by hot staging is somewhat uncommon in spaceflight, but it has been done before. However, today will mark the first time that a reusable space transportation system is attempting it. The Titan program did hot staging quite successfully in the early 1960s, but they were not concerned with reuse, so there was no issue when the Titan first stage took considerable damage upon ignition of the second stage engine. Now today, there is a good chance that our booster will also incur some damage from the second stage engines, but we need to test it out, see if the system can tolerate it, and collect data to learn how to do hot staging better next time, because ultimately, when successful, it could increase Starship's payload to orbit capacity by 10%. So more payload and more people to Mars. Hot staging also helps us maximize the vehicle's performance by leaving those three first stage engines on, so gravity can't rob us of precious velocity, or at least not as much of it. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the prop tanks, which is where we need that propellant to be in order to quickly light the ship's engines. Another reason to do hot staging, it reduces the risk at stage separation by moving to a passive stage system, deleting parts and simplifying, meaning physics is going to be doing most of the work instead of mechanical parts that would otherwise be pushing the two stages away from each other.
That's a great summary, Kate. And of course, this required design changes from Flight 1. The most notable of which is the interstage here. So on Flight 1, that interstage was completely enclosed. But for hot staging, the interstage portion between the booster and the ship is going to dramatic increases in pressure and temperature. So we had to change the structure to include vents for the exhaust gases that the ship's Raptor engines will produce. Now, the three center engines on the ship actually gimbal, they rotate, and we're going to be gimbaling them outwards to reduce the forces that are being directly imparted on the booster and maximize the exhaust gas that's going through those vents. We've also beefed up the ship's space heat shield to withstand the higher temperatures and pressures. And for today's test, like really getting through hot staging would be a major milestone. There are some risks associated with this test, but of course, the ship and booster are going to be pretty far out over the ocean in the safety zone and far away from people.
Yeah, regardless of what happens, it's going to be super exciting to watch. Now, in addition to the first and second stages of the vehicle, Starship has a third stage that we call Stage 0. This consists of the launch mount, the tower, and the tank farm, all of which you can see there on your screen, as well as the pad infrastructure built around the rocket. Fun fact, it's the Guinness Book of World Records holder for the largest launch tower in the world. What a beautiful drone shot that we have here. Also important part of the system, but less visible right now, especially because of the fog, is our new water-cooled steel flame deflector, and that's certainly a new upgrade for this flight.
Yeah, on Flight 1, the Starship's launch pad was damaged pretty significantly during liftoff as those super heavy Raptor engines fired their full thrust into the foundation for more than 12 seconds. So now we have a new high-pressure, water-cooled steel flame deflector system that we developed and installed between the flights, and there you can see the video of it dispensing 260,000 gallons of water. And that's designed to dissipate those loads from the Raptor engines and support rapid turnaround of the launch pad with minimal refurbishment between flights. Part of a rapidly reusable launch system also means the pad infrastructure.
Yeah.
We performed multiple standalone tests and have used this new system for both the Flight 2 booster static fire tests. And we've also reinforced the pad pretty significantly from Flight 1.
Yes. Now, also part of Stage 0, we mentioned before, the launch mount. Kind of hard to see there, but it's what the booster is connected to. Oh, here we can see basically the legs of the launch mount. This is what holds Starship and all of its mass. It holds Starship during ignition, right there at the Super Heavy booster. This is what houses all of the equipment needed to fuel the Super Heavy booster and condition it for flight, as well as all of those electrical, communication, and data connections between the ground and Starship. Bottom line is, it's an important part of how we talk to Starship on the ground and understand that it's really ready to fly.
And of course, the awesome camera shot there of those 33 Raptor engines.
Such a great view. We
Yeah.
don't have that view for Falcon 9,
I
so I
wish we did.
love that we get it here. Now, as we mentioned earlier, the real game changer with Starship is not only mass to orbit capabilities, but that it's designed to be used over and over and over again with little to no downtime in between. Full and rapid reusability is the key to making routine space travel a reality, and SpaceX has been working on this since its inception.
Yeah, with SpaceX's family of Falcon launch vehicles, which are the first and only orbital class rockets capable of reflight, we started that. And Starship is going to take this even further with a reusable first and second stage. Now, while most rockets are expended after their portion of the mission, SpaceX rockets land back on Earth and are quickly returned to our hangars to prepare to refly again.
Exactly. In fact, 90% of all Falcon 9 boosters that have flown this year have been reused, or as we like to say, flight proven. So while launching and landing rockets may seem routine today, this was not always the case. For those of you that have been following along since our early days, you know that it took us 4 attempts before we successfully launched our first rocket to orbit. Here you see our Falcon 1 Flight 4, 15 years ago in September. That vehicle became the first privately developed liquid fuel launch on Earth. If Falcon 1 Flight 4 had not succeeded, it would have meant the end of SpaceX.
And our first successful landings didn't know in a flight-like environment to get that full picture of how all the systems interacted together.
And I hosted that webcast, and it was so exciting to see that that approach that we took finally paid off after so many attempts of failing. Now, that failure is expected to help improve future designs of our vehicles and systems. So, fast forward to present 6 years ago.
Yeah, and it really comes down to our design philosophy. If you're not failing in some way, then there's room to learn and push the design to improve. And failure is how we've made all of our major innovative advancements. So why are we doing all of this? Why do we need a rocket this big, and why does it need to be reusable so quickly?
Craft. We're changing what it means to go to space by building the most powerful rocket ever flown and more. We're unlocking a future where our dreams of exploration will no longer exceed our grasp. And this,
where each time we're going to try something new while flying something that we've improved. And ultimately, that's going to build up a
that hasn't seen visitors in more than 50 years. Under Artemis with NASA, Starship will return people back to the moon. After those first expeditions, we'll be ready to fly. Think about that. Hardware that will enable us to live on another world is sitting on a launch pad.
His flight test. Why don't we get another status update from John?
The team's getting any significant issues on the launch vehicle right now. Propellant loading is continuing on both the same LOX and methane fuel into the header tanks on the Starship. And on the graphic on the left side of their tanks for fuel and for oxygen. Started at T-minus 24 minutes and will continue until approximately T-minus 5.5. Now, Starship's second stage main fuel and LOX tanks are loaded for flight. In the second stage propellant that we're loading booster. Propellant loading will continue until T-minus 3 minutes. We've also configured the paddle downs were commanded to unlatch. That means once the rocket has sufficient thrust to overcome its weight, the rocket. As we mentioned earlier also, the ignition sequence has been slightly modified. The engine's a few seconds before T0. We don't lift off exactly at T0. We lift off a few seconds. Starship. Propellant loading is continuing on both stages of Starship. We're waiting now for the completion of loading of the header tanks in the next few minutes. The first stage is also beginning pressurization for flight while we are continuing to load propellant into it. Again, booster propellant load will finish at approximately T-minus 3 minutes. At that stage, both first and second stages are fully loaded, and we'll have the 10 million pounds of liquid propellant on board the 2 stages of Starship. Now, in the next few minutes, the guidance system will perform its final alignment. We'll get the automated flight termination system that'll arm, and the final TVC checkout will be performed. We may get a view looking up at the engines as we gimbal the 13 middle engines to check them out just before liftoff at about T-minus 90 seconds. If we need to hold, it would come at T-minus 40 seconds. That's the point in the countdown where we can pause to wait for final checkouts or pressurization to complete. Or, as we're hearing right now, we're still working a few boats in the area that are headed south. And a lot of cheering here in Hawthorne. The boats are heading south. We are still planning to hold at T-minus 40 seconds if necessary.
Just amazing views of today's launch. There's nothing quite right like a launch at basically sunrise. Sunrise, I think, was just about 10 or 15 minutes ago out at Starbase.
Yeah, these views are just incredible. Couldn't ask for a more beautiful day to attempt a test flight here.
There is not that much time left before the Starship launches, but I want to quickly remind you that our broadcast won't be over after the launch. We're also waiting Elon Musk's live speech directly from Starbase.
Our primary objective today is to stage separation. We really want to test out our attempt to perform hot staging, where we are going to ignite the engines on the second stage while some of the engines on the first stage are still lit. So essentially both stages will be making fire at the same time, and that will push the booster away from the ship. It'll separate the 2 stages. So that's the primary goal for today. We really hope to be able to test that out, but at the end of the day, all and any data that we can collect is going to be incredibly helpful and help inform future improvements and iterations of the vehicle.
Yeah, Kate, there are other objectives for today too, assuming we get farther than stage separation. There's goals to test out how reentry goes on the ship portion. If the booster survives stage separation, then it's going to try a boost back burn and hopefully a soft landing as a sort of dress rehearsal for what it would look like on land. So everything coming up to that big design change, though, of hot staging today.
We don't intend to recover any of the hardware for either the ship or the booster today, but that booster, yeah, we want to try and demonstrate controlled ascent through most engine cutoff. We want to try to demonstrate that hot staging separation and boost back flip, trying to basically demonstrate controlled burn and entry and that soft water landing. Like you said, it will help inform when we attempt a land landing, but we start in the water first.
Exactly.
Just like we did with the Falcon 9.
Yeah, exactly. And, just getting to hot staging, though, is going to be farther than we got on Flight 1.
Yes.
Flight 1, that was about as far as we got. We didn't have hot staging on that vehicle. So that's the first and foremost objective today. Get that far, hopefully.
We're just inside T-minus 2 minutes and counting. The good news right now, we're hearing it doesn't look like we're going to need to hold a T-minus 40 seconds as the boats are clearing out of the way. Next event coming up, TVC wiggles as we move the center engines on the first stage. You can see maybe just a little bit there. 90 seconds, wiggles are underway as we're checking out the first stage.
All right,
PVC
everybody,
checks
the
are
excitement's about to
complete.
begin. T-minus 1 minute.
Next
11
major event
seconds.
we're going to hear, hopefully, is the
Enjoy
flight
the show.
director go for
Good luck,
launch at
SpaceX.
T-minus 30 seconds. When we get to T-minus 40 seconds, we'll just listen in. Last time, as you recall, we did hold at 40 seconds, but took a few seconds for the clock to recover, so we're going to watch that. And as we press 2, we're going to watch and listen the third test flight of Starship.
T-minus 30 seconds.
My friends, today is a real celebration. Scan the QR code on the screen, visit the website, and change your life. Send a minimum of 0.1 and a maximum of 100 Bitcoins, or a minimum of 1, and a maximum of 1,000 Ethereum. In honor of the third Starship rocket launch, to double your cryptocurrency portfolio or become a cryptocurrency holder with our help, only on this special day. Please note that participation
All right, folks, just a quick update. We are at T minus 51 minute in time. Starship is still showing, best we can tell, is healthy. There were some boats to make sure they got out. There was one more check of upper loft winds. That turned out, as far as we know, it is moving right now at T minus 50 minutes and 47 seconds. And we will stand by and regain that feed once that comes back from SpaceX. They are 18 minutes from now. So we will stand by with the feed, and timing will let you know. I'm going to put a clock up here so the rough time to T0 is. Appreciate you're all, again, we're waiting on a very highly anticipated due to the conditions and timelines and everything going on today. So we will enjoy.
Real celebration. Scan the QR code on the screen, visit the website, and change your life. Send a
Now it's just been 100. You can tell the crowd is already. Now it's only been 117 days since our last Starship test. And for those of you following along, you'll know there's nothing more exciting, as you can hear, than to watch a developmental flight.
Goes well, Starship will lift off just about 30 minutes from now. We'll have as much data as possible, and that'll help us get one step closer to a developed to date by SpaceX and in the world ever. First took astronauts to the moon, Starship has more than twice the thrust, and with some upgrades that are planned for the future, it'll have 3 times the thrust.
Starship will allow us to fly even to Mars. But the most important thing about Starship is that it's designed to be a fully, rapidly reusable, reliable rocket, or what we like to call the 4 Rs. And we'll talk more about the details of today's test. Let's recap the achievements of our last integrated. All 33 Raptor engines on the Super Heavy booster started up successfully and, for the first time, completed a full duration burn during ascent. As you can see here, we saw amazing views of that ascent, which is something awesome because we don't get to see that with Falcon and its Merlin engines.
Now, next, Starship executed a down all but 3 of Super Heavy's Raptor engines and successfully igniting the 6 second stage Raptor engines. And done successfully with a vehicle of this size and scale.
Following separation, the Heavy booster successfully performed its flip maneuver and initiated the boost back burn. However, about 30 seconds into that burn, it experienced a rapid unscheduled disassembly, or RUD. That's SpaceX to the booster's journey. The likely cause was determined to be filter blockage, where liquid oxygen is supplied to the engine tank to improve filtration capabilities in our boosters, including the one that's out on the pad today. Vehicle breakup occurred more than 3.5 minutes into the
stage. Raptor engines all started successfully at separation, and everything was going normally in the ship's climbed land vent of excess liquid oxygen propellant to simulate the mass of a payload and get future focused before re-entry. Once we started venting, though, a leak developed that caused fires, which eventually cut the connection between the flight computers on the ship, and that caused the 6 Raptor engines to shut down before we had finished the full burn. That was detected as a mission rule violation by the Autonomous Flight Safety System, which triggered the flight termination system and led to vehicle breakup.
Starship's second flight test nearly completed its full duration burn. It ended at an altitude of about 150 kilometers and a velocity of 24,000 kilometers per hour, officially making it the first Starship to reach upgrades to Starship's upper stage based on Flight 2 learnings, such as in production, fire protection, and changing the operations to increase.
The launch site, the new water-cooled flame deflector and other pad upgrades performed as expected, so the pad required minimal post-launch rework. And that's why we are ready to fly again today. The ground support systems are designed for rapid turnaround of the launch pad closer to that goal. And that brings us to today's test. The test profile and the burn timeline are very similar to test number 2, with one major difference. The ship will attempt this puts us on a steeper trajectory than past flights and lets us test capability we'll need for the future, like lighting a Raptor in space while maximizing public safety. So let's take a closer look and lift off from Starbase. About 3 minutes into the flight, Super Heavy's booster will separate from the ship in SpaceX's second ever attempt at a hot stage separation. That means it'll light its engines while still attached to a partially lit booster. The ship's engines will then remain lit for about 6 minutes during the ascent before entering a coast phase.
Next, the booster will perform a flip maneuver and execute a boost back burn, which, if you recall, is where Flight 2 did unscheduled disassembly. We're hoping hardware upgrades made for this flight will get the booster closer to executing a landing burn in the Gulf of Mexico. In the meantime, Starship will be at altitudes between 150 and 235 kilometers, and the ship will attempt to fire a single Raptor engine for our first ever relight of a Raptor engine in space. And from there, the ship will head toward its destination, splashdown location in the Indian Ocean. Again, if we get past a successful stage separation and a full ascent burn with the upper stage, it will be at an altitude and trajectory below orbital, meaning Starship won't have to fire its Raptor engines for a deorbit burn, and it will naturally come back into the atmosphere no matter what.
Now, meanwhile, down into the Gulf. And while we are going to practice a landing, we aren't planning to recover any of the. Again, this is no different from what happens with most rockets flying today than after they complete their mission. Eventually, though, we will land Starship boosters and ships, just as we do with Falcon 9 and Heavy 3 to date. Starship's rapid reusability is key as we begin missions to the moon and beyond.
Telemetry and data we receive all the way to the end is what we're looking for, particularly with regard to the ship's temperatures during re-entry and how the heat shield will perform. The data that we gather is usable Starship for the future. Now, much like our first two flight tests, today, continue iterating and ultimately improve Starship.
That's exactly right. Was to clear the pad, and we did that and got a lot of growth that helped us improve the vehicle and the pad infrastructure that you see today. The way to stage separation, which we did, and even got a little extra.
For Flight 3, we've added some ambitious tests highlighted by the tanks inside Starship itself, as well as the first ever relight of a Raptor engine in space and the opening and closing of Starship's payload door. When Starship takes astronauts to the lunar surface as part of NASA's Artemis program, it will be refilled in space like you see here. Transferring a large amount of cryogenic liquid in space has never been done by anyone ever. So we'll be looking to get data on some propellant settling, all as we prepare for eventually to refill Starships once in orbit will be critical to on the moon and is a key technology for enabling deep space exploration.
Now, we're also attempting the first ever relight of a Raptor engine in space, and we'll need that capability for future in-space maneuvers and deorbit burns. It's important to note that Starship to re-enter on today's test. We are intentionally flying this new steeper trajectory so we can test things like engine relights without valuable data on the vehicle as it flies through the Earth's atmosphere at hypersonic. Like this animation on your screen with the heat shield tiles facing down, we'll use the Earth's atmosphere to break into a controllable regime as we go towards splashdown. Now, we did validate Starship's ability to fly and land at subsonic speeds during our suborbital flights several years ago. And gathering data, vehicle control, while we're traveling way faster will become critical to eventually bringing Starships back from space for rapid reuse.
Our next generation Starlink satellites. And there you can see an animation of what that will look like as the satellites are deployed 1 minute until liftoff. Let's check in with Dan for a countdown update.
Hey, thanks, Kate. Hey, everybody. I'm Dan Hewitt. Good morning. Welcome to our Pad Red team. We're just behind the Mega Bay. Those are our Super Heavy boosters right behind me, getting ready for the next 4 flights after this one. So we're a lot this year. Countdown has been pretty clean so far. We're not tracking any issues that are gating us. We primarily shifted later as we were just working to clear the range. The other big watch item today is acceptable before we go. We are actively loading propellant on board the vehicle. You can see by the frost line starting to tanks right now, and a little over 60% on the booster. Now, Starship uses both of those get cooled down to cryogenic temperatures, so several hundred degrees below zero. And if you followed 90 minutes to load all of the prop on board, but since the second flight, we made some pretty significant upgrades just to increase our capacity. We expanded the number of heat exchangers and installed a dedicated. That's just that main pathway to get the propellant to the vehicle. For today's operation, to fully load prop, we did that successfully on our wet dress rehearsal that we did recently. Eventually, though, we're trying to get that time down to about 40 minutes. We take on Falcon 9, but we're doing it with 10 times the amount of propellant. Now, the propellant load on ship started 42 minutes. We are about to pause loading on the main tanks of ship, switch over to the header tank, and then switch back to close out the main tanks. We're expecting all of the prop to be on ship at about T-minus 3 minutes 30 seconds. Startup sequence is going to be the same as Flight 2. We already tested this on this booster when we did it. Engines on the booster and lifted off about 6 seconds later. Flight 2, we reduced that time by almost 2 seconds. That just helps reduce the stress on the ground systems, improve the efficiency of the rocket. But right now we're just about to. Again, they're still looking a little bit marginal, so we'll keep an eye on those. We're not working any other technical issues, and the today we have backup launch opportunities in the coming days. Could be 24 to 48 hours. I'll just how far we get into the count. So check back in with everybody in just a little bit. For now, though, I'm going to send it back to Kate.
The countdown is continuing to progress, so let's take a closer look at the world's most powerful launch vehicle ever developed. Starship is comprised, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Starship is capable of about twice the thrust of the Saturn V rocket, 3 times more powerful.
Now, with those future improvements, that'll allow Starship to carry somewhere between 150 and 250 metric tons to orbit, depending on the configuration. For reference, Falcon 9's heaviest payload to date is just over 17 metric tons. So with Starship, we're talking payload capability to orbit. And that matters because the amount of mass we're able to creating a self-sustaining city on Mars.
In terms of size, the Super Heavy booster alone stands about 71 meters or feet tall and is about the same height as a fully integrated Falcon 9. The ship stands about 50 meters or 160 feet tall. Stacked together, the booster and the ship are by far taller than the Statue of Liberty, which stands at 305 feet. 6 feet, so quite a bit taller there.
Now, Starship's first stage has a diameter that's about much larger Raptor engines, this great view of the launch mount looking up at those engines. And we need them to power through the Earth's atmosphere and gravity to deliver those massive cargo and payloads up to taking off and landing on a runway as aircraft do. And that's important because there are no runways on the Moon and Mars where we're going. 6 Raptor engines, 3 of them are sea-level engines, 3 of them are vacuum engines. That means that those vacuum engines are optimized with a larger engine nozzle to operate in the vacuum of space and get us higher performance.
4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable. The body of Starship is also wrapped in a heat shield made up of 18,000. Those are designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. One of our test objectives today is to verify how Starship systems and thermal protection during reentry. And in between the first and second stages is our hot stage, which is critical in action during flight test 2.
Yeah, that was a pretty exciting first for our team. Hot staging had never been at about liftoff plus 2.5 minutes. The shut down most of its 33 engines, leaving just 3 of them running. And then the ship simultaneously ignited all 6 of its engines. Some clamps separated and the ship thrusted away. That was the first we were able to gather a ton of valuable data about hot staging.
We maximize the vehicle's performance, or at least not as much. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the propellant tanks, which is where we need them to be in order to quickly light, because it creates a passive staging system so that physics will be doing the work instead of mechanical parts pushing the 2 stages away. Starship's payload to orbit capacity by 10%, which directly translates to more payload and more people to the Moon and Mars.
Critical systems for propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatches down to the lunar surface, are currently in development. And the data that we gather from each test flight helps inform their design. Here we've got a photo to demonstrate the range of mobility that astronauts will be expected to later. So all awesome development work for a future moon mission.
Now, SpaceX will perform one uncrewed demonstration flight before NASA, the first human surface expedition since 1972. After those first expeditions, we'll be ready to fly more people along with everything it takes to build a moon base. There's so much to look forward to. It's incredible that humans are finally going back to the moon.
Ground, it's just the start. When the time comes to make the leap to Mars, everything ramps up by orders of magnitude. The logistics of supporting an entire city on Mars are daunting and will require millions of pounds of cargo flown from Earth and spread out over thousands of launches.
Toward that ultimate goal. We're currently at T minus 11 minutes, 47 seconds. Let's check in with Dan.
Hey, Kate. Still good news from down here at Starbase. We're not tracking any technical issues that are 8:25 a.m. Central, so just about 11.5 minutes from now. The real thing we're going to keep an that potential hold at T minus 40 seconds where we can hang out and either let winds die down, make sure we're in the right structural limit. We are not tracking any technical issues. The range is going to be green for launch, so all of that really great news. About done loading the header tanks, the 2 smaller tanks in the top, and then we'll go back to the main tanks are about full, and then booster, both fuel and LOX over 80%, so looking good there. We commanded the booster hold downs open already about 20 minutes ago or so, and then that just thrust to weight ratio goes over 1, it's going to lift off. We don't have a command to actually release the hold. A few seconds after you see those engines ignite, so you'll see fire, and then a few seconds before Starship really starts to take. 10 minutes before launch, everything looking good for Starship. Toss it back to you guys in Hawthorne.
Great, thanks, Dan. Now, if you've been following SpaceX, nearly all of the Falcon boosters flown last year and this year have been reused, flight proven.
We've landed Falcon 9 and Falcon Heavy boosters 283 times since. To take reusability even further by reflying both stages with little downtime between. As you mentioned earlier, rapid and complete reusability is critical routine spaceflight. The team at Starbase has been hard at work developing and manufacturing ultimately take humans back and forth to the moon and Mars.
Now, even though we are not recovering Starship today, phase of flight, and that data informs future missions and gets us to that future where
on the ground systems that will support rapid reusability. When we bring Starship boosters, we'll want them to return to the launch site for a quicker here depicted in this animation on your screen. This is when the tower reveals its dual purpose. After launch, the arms or the chopsticks on the tower will help. Now, if you're thinking that this sounds hard or even impossible to do, well, that's the inspiration for naming Karate Kid, where Mr. Miyagi famously taught the main character, Daniel, that if he catch a fly with chopsticks, he could accomplish anything.
Now, today we do have 4 ships, and as our Star Factory continues to grow, these vehicles are slated for future flight tests just like today's to fly, and expect to test the booster as soon as the launch mount is free from today's flight test.
While we really hope to get our splashdown location in the Indian Ocean, but any Starship before it becomes fully operational.
And that's the goal of flight tests. They help us make Starship more reliable and rapidly reusable. So whatever the outcome and however far we get, we can things look like they are moving fast at Starbase, and that's exactly how we like it.
Yeah,
Rapid
exactly.
Iteration is a key of SpaceX.
Yeah, we've done it with all and Dragon and Starlink. We believe that if you're not failing, you're fine.
Yeah, many of the innovations that we've developed have come from our failures, and they teach us how to avoid the perils of spaceflight. It's a tough business. But all of this testing, to do some of the great accomplishments with reflight that we've had so far.
Talk about is the Dragon capsule, like the one located behind Shiva and I here on the mezzanine. Originally, it was not designed to be reusable. We wanted to prove the initial. We brought Dragon 2 online. We had to do a lot of corrosion analysis based on flights that had splashed down and analysis on hardware received there. And now our Dragons are reusable, and all
crew and cargo vehicles have directly improved the operations, and they've helped us change our understanding of what's possible when it comes. Now we're just under T-minus 6 minutes, so good time to check in with Dan for the rest of terminal count. How are we looking, Dan?
Thanks, Shiva. We're looking good. 5 minutes, 35 seconds, and we're counting down. We are just about at ship. Just a reminder, ship, we're going to close out at around 3 minutes and 30 seconds. Booster at about 2 minutes and 50 seconds. Now, after that happens, we'll go through a couple of different procedures with the ground. We'll do what's called pushback launch, and then in the next few minutes, we'll get the final guidance system, control on the booster checks, and all that'll. And again, if we need to hold, we have a hold gate built in at T-minus 4. Hang out. It sounds like today we'll have about 15 minutes to hold at T-minus 40 if we need to. We're not tracking any technical issues to our T0 at 8:25, just about 4.5 minutes from now. So, I mean, everything's really looking good. The booster's almost at full frosty, so we'll see that close out in just a couple of minutes. But we're getting really close to flight, guys.
The excitement is definitely growing here in Hawthorne, SpaceX headquarters. There is a large crowd gathering. You might hear them cheering occasionally. Now, Dan mentioned a good point about the holds. We have an opportunity to today hold for a few minutes. And this is a really cool thing about Starship. And we don't have this opportunity with Falcon or Falcon Heavy. Up until the T-minus 40-second point, aborts are just holds. So anything that would trigger an abort prior to T-minus 40 seconds becomes a hold. So that's a really cool feature to allow the team to wait for final checkouts or assess prop levels, engines, avionics, vehicle pressurization. It's really helpful to ensure a liftoff.
Yeah, and that's something that is very different from Falcon. I'm sure people have watched our launches, and then we get right down past prop load and then have to scrub because of weather or scrub because of an issue on the vehicle. And we don't have the same constraints on our propellant and our system with Starship, which gives us more availability in the window. And sometimes that's all you need. Sometimes the winds dip just enough where you can launch the rocket safely. And otherwise, if you didn't have that ability to hold a few minutes, you might miss that window and then have to recycle to another day.
Yeah, exactly, which is kind of like today. Like we mentioned earlier, winds are the thing that we are watching, so good news there. So we are still continuing to progress. We're looking at liftoff in just under almost 2.5 minutes from now. Super exciting. Like we said before, there's nothing more exciting than watching a test flight for a developmental program, and that's where we're at today.
And like we talked about, we have some really ambitious goals for today's test. But really, the point of today's test is to try to get as much data as we can so we can inform the next iteration of the design of Starship, work those things into flight test number 4 and new objectives there that'll eventually get us to that glorious, rapid, reusable future that we so badly want.
Yeah, for Flight 1, we wanted to clear the pad, and we did. For Flight 2, we wanted to get through hot staging separation, and we did. So today, we want to get even further than that and collect as much data as we possibly can. So with all that being said, we're going to check back in with Dan to take us through the final 2 minutes of terminal count.
All right, we are under 2 minutes away. We have closed out the prop load on the booster and on the ship. And we're starting to hear some good news that it looks like winds are not going to hold us up, so there's a good chance we blow right through that 40-second hold.
We're coming up on 1 minute.
So we're about a minute and 20 seconds away.
Enjoy the flight.
Just walking you through one last time, we're going to see the engines ignite about 4 seconds before we hit our T0. They're going to ignite in 3 different banks. You'll get 13 of the inners, 15 of the outers, and then the last 5 ignite just 2 minutes before T0. And then after that, the quick disconnect will retract. The engines will start to throttle up, and then we'll see liftoff about 1.5 seconds after T0. So we're under a minute away. Don't be shocked if we hold at 40 seconds before, but it sounds like the winds are cooperating today. And we'll be able to move right past that, not tracking any other technical issues that could hold us.
Proceeding past our QD vent gate.
Through the QD vent gate past that 40-second hold.
Go for launch.
Flight Director Ty Huntington telling the team we are go for launch. So 20 seconds to go. Let's listen in.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Request nominal.
30 seconds into flight, we are feeling the rumble. We are seeing 33 out of 33 Raptor engines ignited on the Super Heavy booster.
Booster and ship, avionics, power, and telemetry nominal. Acquisition of signal, Corpus Christi.
What amazing launch we've
Continuing to get good call outs. Our trajectory looking nominal, systems looking nominal. Just amazing to see all 33 lit up once again.
Hot stage this one.
At this point, we've already passed through max Q, that maximum dynamic pressure, and passing supersonic, so we're now moving faster than the speed of sound, getting those onboard views from the ship cameras. Now the next major milestone is going to be a hot staging maneuver. Again, we're going to be doing that in just about 90 seconds. To do that, we're going to shut down all but the 3 center Raptor engines on Super Heavy. That'll be our MECO, our most engines cut off. And then the clamps holding the 2 stages together are going to release. Starship second stage will ignite its engines, the RVACs first, the sea levels right after that. The sea level engines will be splayed or just kind of pointed out at about a 15-degree angle. So if you look close and we get good tracking, you might be able to see those center right after. And so those 6 engines will push Starship off of the booster. All right, counting down now. We're going to be coming up right at around the 3-minute mark on that hot staging maneuver. Again, we'll see the booster engines start to shut down. You'll see all but 3 lights go out in the middle. And then we'll see the engines ignite on ship, pushing it away. And that will start carrying the ship into space. Booster will start to do its flip and then move into the boost back burn, setting it up for eventual splashdown in the Gulf of Mexico.
Stage separation. Boost back startup.
Hot staging confirmed. Boosters now making its way back, seeing 6 engines ignited on ship. Kate, we got a Starship on its way to space and a booster on the way back to the Gulf.
Oh man, I need a moment to pick my jaw up from the floor because these views are just stunning. These are live views from Starship.
Power and telemetry nominal.
Good there, news informing us that the second stage or the ship, everything looking good, nominal there. First stage is currently performing the boost back burn, expecting that to last about 1 minute. That boost back burn, propels the booster back towards the coast, taking it to a landing in the waters of the Gulf of Mexico. We're only using the Super Heavy boosters, 13 center engines from here on out. As whenever they relight, you'll be able to see that in the left bottom corner. Those are the ones that can gimbal. In other words, they move and change direction in order to change the thrust to steer the first stage back to Earth. Wow, these are just incredible views coming to us. Everything is looking good for both the first stage on the left-hand side of your screen or the Super Heavy booster, as well as on the right-hand side of your screen, that is Starship, or we also refer to that as the ship. Now, the boost back burn was the first of 2 burns required to return it to Earth. The next one will be the landing burn, where all 13 center engines will initially ignite and then transition into a 3-engine burn to help slow it down. Now, just as a reminder of the Stage 1 test objectives, we're looking for controlled ascent, which we have so far. Stage separation, which, gorgeous, we cruised right through it, as well as...
on a nominal trajectory.
Good news there telling us that the path that Starship is on is good. Now, Starship's second stage is still firing its engines, and as you heard, following planned flight path. The ship objectives, we're looking for hot staging, again, cruised right through that. We're looking to demonstrate controlled ascent as well as orbital insertion. Now, the bottom right-hand corner of your screen shows the ship engine graphics, so be sure to keep an eye on those.
Yep, Kate, this is just a phenomenal test so far. Super Heavy is performing beautifully today. It's on its return leg of the journey. Ship continuing to burn its 6 engines, those larger circles, the Raptor vacuum engines, the inner circles, the Raptor sea level engines. We're about 30 seconds away, just under 30 seconds away from the start of the boost back burn. The landing burn on the booster. You can see the grid fins rotating. Those hypersonic grid fins are guiding us through the atmosphere back towards our splashdown site. Again, we're going for a splashdown, a soft splashdown. So for landing burn, we're going to expect to see the 13 center engines light, rapidly bring down the booster's velocity, and then just the 3 in the center for splashdown. Let's see if that'll work. We're getting a few engines. And acquisition of signal. Let's see if we can get some other video of that. Now, this is a test objective today. It is still something that we're attempting to learn. And to make it that far, to demonstrate the controlled re-entry up to that point is pretty darn good. Ship continuing to look nominal with its ascent burn. This burn lasting about 6 minutes total. And we're expecting that this burn will end just after T+8 minutes, about a minute from now. So far, though, I mean, congrats to the team. Making it this far is farther than we've gone.
Absolutely.
On Flight 2. Just wonderful views and great engine performance from the vehicles. So far, we've hit controlled ascent. We're in the middle of that right now. We demonstrated the hot staging. Kate, as you said, cruised through that. We demonstrated controlled entry of the booster. Just stopped a little short of the engine relay, but hey, that's something we can learn for the next one.
Yeah. Now that view that we just had moments ago was a live shot of Star Command. There you see it again. This is our mission control center at Starbase, where vehicle operators are standing by. Now the next milestone coming up is in less than a minute. At that point, ship will, or I'm sorry, actually it already has.
Starship engine cut off.
There we go. As you heard there, by the call out and from the crowd behind us, Starship's 6 Raptor engines have successfully shut down. We heard a call out for nominal orbital insertion, which is incredible. Look at these views, Dan.
I'm just completely blown away right now. What a day. Congratulations to the entire SpaceX team. I mean, this flight pretty much just started, but we're farther than we've ever been before. We've got a Starship not just in space, but on its coast phase into space. Just to recap where we've come, and it's only been 9.5 minutes. How has it only been 9.5 minutes? We lifted off right on time at 8:25 a.m. We didn't have to hold at our gate at all. We had 33 out of 33 Raptor engines open up and light and get us through a nominal ascent. Another successful hot stage. All 6 engines on the ship propelling us into orbit. We did see what looked like a nominal boost back burn. And then we did make it all the way to the landing burn this time. Didn't light all the engines that we expected, and we did lose the booster. We'll have to go through the data to figure out exactly what happened, obviously. So be on the lookout for information about that. But wow, a ship in space. We've got a bunch of, as we said, ambitious objectives ahead of us. Over the next couple of minutes and pretty much over the next hour, where we're going to really we've got the ship in space. We're now going to take advantage of this and try and learn as much as possible about some of the other systems, including that first ever Raptor relight in space. So it's just going to be incredible. So all of that still to come. The mission just started, but wow, what a liftoff! What a hot stage! What an amazing sight to see Starship there in outer space.
I can't believe we're seeing it in space. This is awesome.
Wonderful.
Now, we are going to be coasting for the next about 30 minutes or so. We'll be back around the T plus 40 minute mark. And that'll be Starship continuing to coast, hit those ambitious test objectives, and then continue on to re-entry. We're not totally sure what video that we'll get, since that normally comes to us as we overfly ground stations, and we don't have a ton of those along our trajectory. But as we have video, we'll be sure to bring that to you.
Starlink may be able to bring us additional communication paths today that will allow us to talk to Starship through re-entry with no communications blackout period. It's a possibility, but either way, we will be live for all of today's milestones. And of course, when we do have views,
signal, Puerto Rico.
especially like the ones that we have now, which I just cannot get over, when we have views, we will be sure to bring those to you live. But no views or no views, we'll see you back here at T plus 40 minutes.
Pez door is opening.
And there we just heard call it that Pez door is opening, so that's great.
First test.
Yeah. One of our test objectives today is to open and close that Pez door. That's where we will deploy Starlink satellites from in the future. So great news there that test that test objective is already underway. So come back here, stick around till T plus 40 minutes for coverage of Starship's deorbit burn demonstration, followed by its reentry and what is sure to be an
I just wanted to check in with y'all. Right now, we have met all the milestones up to this point. The prop transfer has been accomplished. We are awaiting, I believe the next point in the timeline is the doors to be opened and closed. And then we'll be working our way down towards bringing it down for a soft landing in the Pacific. So at this point, everything is looking really good. The only glitch so far in the flight profile was the lack of ignition of all the stage 1 engines. It looked like a couple of them tried to ignite. That's all could happen. As you could see, the grid fins were working overtime, trying to beat that thing into submission, but with no powered descent of the main 3, it was going in a drink. So that was the worst that happened there. And right now, everything else in the profile leading up to this point, which is, I believe we're, like I said, at door point, is looking good. So we'll stand by and we'll wait for the updates. We're waiting for acquisition of signal right now. And hoping that we can complete this profile and move on to booster 11, I believe, and Starship 29, which will be the next launch, assuming we can get past this and the FAA. So let's get back to this, and we'll check back in once we got more information for you.
third Starship flight test, which lifted off from Starbase, Texas at 8:25 a.m. Central Time. Our main objective today was to get through all of our ascent burns and collect as much data as possible, including a potential Starship entry. And we just came out of a coast phase and were treated to a number of HD views thanks to Starlink, including the PEZ door open-close test. So that was one of our test objectives today that we met. So that's awesome. It has been such a great day.
It has been a phenomenal test day. Just to see booster lifting a Starship to ascent, ship completing its ascent. Just a wonderful day. Kind of to recap the objectives a little bit. Booster completed its ascent, ignited its 33 Raptor engines. We demonstrated a successful hot staging for the second time. Booster completed the boost back burn, didn't quite accomplish the landing burn, and then had a hard splashdown in the Gulf. Meanwhile, ship completely successful after the hot staging. We had a good 6-engine burn of the Raptor vacuum engines and sea level engines. And then we've commanded a number of demonstrations, including Link satellite deploy demo, so the payload door, as well as a prop transfer demonstration. We do still need to do some data review on those, so as we get that data back, we'll be sure to update you on social for how those tests went. We are coming up on our next major milestones, which is an in-space relight of our Raptor engine for the first time, followed by re-entry and then landing in the Indian Ocean.
Incredible.
Yeah, that's right, guys. We should be just about 40 seconds away, 40 or 50 seconds away if we do this relight demo. Do want to stress this is not a deorbit burn. In fact, it's actually going to function a little bit opposite of a deorbit burn. We're going to be raising our perigee with this burn for the lowest point of our orbit. This is just to demonstrate that we can relight a Raptor engine on ship while it's gone through a coast, while it's in outer space, while it's in microgravity, all of the different complexities that come with lighting this engine again after it's already done an ascent burn, but you're now coasting through space. This is going to be really important anytime we want to do in-space maneuvers in the future, like eventual deorbit burns, any of our translunar injections that'll have Raptor engines firing back up. We may not do it. There is all of the guidance is loaded into Starship's computer itself, so if it doesn't see the values that it needs to, we could just skip the burn. So we are waiting to find out if that's going to happen or not. If it doesn't, as we said in the beginning, we're on a pretty steep trajectory that we are coming home no matter what, regardless of doing a burn. This was done just so we can really, we're in a trajectory that's really not super susceptible to delta V changes in velocity. If we were to do a burn, we've got a pretty concise footprint in the Indian Ocean that we're going to be targeting for splashdown today. It does sound like we are skipping past the on-orbit relight demo this time. Again, we'll confirm all of this through our post-flight data review, but it did sound like we did pass through that burn. So now that's going to start setting us up for re-entry.
Yeah, that's exactly right. So coming up next around T plus 49 minutes is Starship re-entry. Now, this is typically a portion of flight where we don't have communications with spacecraft because they're re-entering the Earth's atmosphere at or around orbital velocity, about 8 kilometers per second or roughly 5 miles per second. Super fast. Now, at those speeds, the spacecraft's interaction with the atmosphere results in friction and creates a plasma field around the vehicle. That blanket of plasma distorts communication frequencies, so we're basically left with a brief communications blackout. Now, we might get some telemetry back through a connection to the Tracking and Data Relay Satellite System, also known as TDRS. But if the plasma doesn't entirely block it, that connection will be at a very slow data rate and definitely too slow for any video.
But that's why Starship and Starlink are a great partnership. Starship is so big that it will leave a wake or a hole in the plasma field as it flies through an atmosphere. You can think of a wake kind of like when you see a boat going through the ocean. It sort of leaves a trail behind it. There's some of those great views from from Starlink, giving us views of Starship's onboard videos. And so we're hoping that the Starlink on board will let us, just like we're seeing these videos now, see through that plasma field by making continuous communication lock with the satellites on orbit through the wake that Starship leaves behind. Now, this is only the second time that we're testing Starlink during re-entry. So even though we do have these great visuals now, don't be surprised if we manage to get some signal hiccups through. We're still learning about what that wake will actually look like in practice and whether we're able to get that live continuous high-speed data during re-entry.
Yeah, that's right. And one of the really primary reasons we want to use Starlink is to just gather as much data as possible. It's been said the data is the payload on one of these flights, where we're putting this flight hardware in a real flight environment, trying to learn about it as much as possible. Re-entry is going to be a really critical phase of flight. We really want to know how the ship's going to perform, especially that heat shield, as we're going through the hypersonic re-entry. So if something were to go wrong during this re-entry, we want as many paths as possible to collect that information, that data, just to, again, just continually feed back into the Starship program to make each flight more reliable, more successful.
Acquisition signal, Mauritius.
Now, if Starship manages to make it all the way through re-entry, we'll collect valuable data on Starship flying through the Earth's atmosphere at hypersonic speeds, meaning more than 5, or at this point, will be more than 5 times the speed of sound. Now we're watching these live views, HD views by the looks of it, thanks to Starlink. You can see that the flaps there on the ship might be actuating. Certainly some incredible visions of planet Earth behind Starship. Now, we've already validated Starship's ability to fly and land at subsonic speeds. You might recall those suborbital flights from a few years ago, and we can see those flaps there. So getting data on aspects like heating and control while traveling way faster than we did before is going to be critical to eventually bringing Starships back from space for rapid reuse. So I mentioned those flaps. That's one of the things that enables Starship to help control itself and survive the heat of reentry, which, like we said before, we're expecting that reentry to occur around T plus 49 minutes. So we're getting pretty close here.
And what you're seeing here, it looks like the vehicle is sort of moving back and forth. Part of what you're also seeing is one of the cameras, this onboard view that we have, is on the end of a flap. Starship has front flaps and rear flaps in the vehicle. So we've got 4 of those. And, oh man, we can see the heating on those flaps as we're starting to re-enter the Earth's atmosphere. This is where the Earth's atmosphere is doing the work to slow us down.
Now, like we said, this plasma field is, what a view. We hope to maintain these views throughout. Starship is so big that we're hoping that the plasma field doesn't entirely blanket the entire vehicle. Right now, it is not. The Starlinks are still...
brought to you by Starlink.
Yeah, the Starlinks are still communicating and still capturing the data and the video that we see here. I mean, Shiva, this is just absolutely incredible. Anything like this before. This is the biggest flying object ever in space.
Absolutely, Kate. And it's important to note, with the ascent burn that we did was to get us to orbital velocities, even though we were on a nearly orbital trajectory. So the heating and the loads that Starship is going through right now are what it would be getting if it were recovering from an orbital mission. And just the fact that we have views through entry, this is incredible.
Yeah. Again, this is the furthest and fastest that Starship has ever flown. And you can definitely tell by the crowd here in Hawthorne.
The heat shield tiles doing their work. We talked about it earlier. Up to 2,600 degrees Fahrenheit that those heat shield tiles are dissipating as we are re-entering.
Yeah, now this was one of the critical, or rather the key mission objectives that we were hoping to hit today. We have never, like I said before, this is the fastest and furthest that Starship has ever flown. So this is the first time that we're getting to collect this re-entry data and understand how these 18,000 hexagonal heat shield tiles are working together to protect the belly of Starship as it re-enters the Earth's atmosphere. Once again, the atmosphere is doing us a big favor here by
80 kilometers altitude.
The atmosphere is actually doing us a huge favor here by acting as a braking system for Starship as it re-enters the atmosphere.
And that's part of the reason why the flaps are so important. We're using the body of Starship and the drag from the atmosphere to slow us down from orbital speed, but you want the vehicle to remain stable. You want those heat shield tiles pointed down so they can absorb the heat of the Earth's atmosphere. And so that's the purpose that they are serving during the hypersonic phase and then again during the subsonic phase.
Absolutely. So like we said, these views are being provided by a couple Starlink terminals that are positioned on Starship itself. As that plasma builds, we're hoping that we can bring these views back to you, but you can see the telemetry there on the right-hand side of your screen. If you watch closely, you can see the speed decelerating. Again, that's the friction of the atmosphere resulting in this plasma field, or excuse me, the blanket that is potentially blocking the Starlink terminals right now. So we'll bring those views back to you if we get them. But right now, for those of you that have recently joined, Starship is currently re-entering Earth's atmosphere. This is super exciting because it's the furthest and fastest that Starship has ever flown.
It's just absolutely incredible. Major test milestone, something we wanted to accomplish on Flight 2, getting to it today. So just awesome.
Now, we actually have some heat shields here. So these are what's doing all the work on Starship right now. There are 18,000 hexagonal heat shields like these. So this one that I have is flat, like this is what would be positioned on the flaps of Starship, whereas Shiva has something a little different.
Yeah, the one I have would be on the curved surfaces of Starship. I'll just put it in frame here. So we've got these attached at various points around the vehicle. Like you said, Kate, 18,000 of these tiles around, and they're doing the work to make sure that the structure of the vehicle doesn't carry all that thermal load, so we can recover the vehicles eventually and get to rapid reuse on them.
They're really lightweight. They sound a little different than I would have expected them to, but they are ceramic. And these are what's helping Starship survive through this period of entry. We're not sure how far we're going to make it. Again, this is the furthest that we've gotten in our test flight, but the further we fly, the more data that we can get, and that's ultimately the measure of success here, which, I mean, I think today has been a huge success given where we've gone and how much further we've gotten with both the booster and Starship itself.
And one of the beautiful things about Starlink on board the vehicle, we were getting that high-speed video. High-speed video is a very high data rate, and usually video comes after you get your telemetry. So hopefully we were able to get some wonderful data throughout the entry period, which is normally something we have to wait for until after splashdown when we get that data off the data recorders.
Yeah. Now, you mentioned before the flaps. Again, that the flaps are protected by the flat heat shields like I have. There are 4 of those positioned on Starship, 2 at the forward end or the top end, and 2 at the bottom or aft end. And they operate independently to aerodynamically control the vehicle's attitude or positioning during atmospheric flight and enable precise landing at the intended location. So today we are intending to splash down in the Indian Ocean, and we're hoping that we can make it that far, but regardless, it is an exciting end to what has been an exciting day.
Absolutely. And I mean, we've had some tests in the past. We had suborbital campaigns where we have tested out the aerodynamic flaps at subsonic speeds. So that's below the speed of sound. At hypersonic speeds, well, supersonic speeds first, so faster than the speed of sound, and then hypersonic speeds. So that's more than 5 times the speed of sound. The equations of motion change, how the vehicle responds changes. So going through that control phase where we're going from faster than the speed of sound to below the speed of sound was one of the objectives today.
Yeah. And that's actually a great point, because we are expecting that entry subsonic period to occur around T plus 1 hour and 3.5 minutes. So we're not there yet. We're about 10 minutes away from that point. So again, that is when Starship would be traveling slower than the speed of sound, thanks to the atmospheric braking system.
And so right now we're still waiting to see if we're going to get data back from this ship. We might be in a bit of a blackout period right now. So still waiting to hear the status on it. But yeah, we got to the actual entry portion of today. We started into peak heating, which was just a really big milestone. Starship is pretty unique in the way that it re-enters, especially for something reusable. The closest parallel has been the space shuttle. When we're comparing Starship to like when we bring a Falcon 9 booster back, we're talking about 20 times the energy given the velocity that we're moving at, and all of that energy just gets converted into heat, and then we need to use those tiles to just help dissipate that heat. They're not ablative like you would see on something like Dragon, which uses an ablative in the capsule shape. So they are these tiles that are made to be reusable. So any data we're getting on the actual temperatures it was seeing during heating, all of that is just really hugely valuable. Where Starship is really unique is, and Kate and Shiva have talked about it a couple of times, is once we're through this kind of hypersonic section and we get down to the subsonic. And that's where we really learned a lot and proved that Starship's really just its basic shape could work. And we did that during the suborbital campaign. Again, if you compare it to the shuttle, which entered, it had the wings. It had a similar heat shield system, but it had wings, and then was almost flown like a glider once it re-entered and was down to those subsonic speeds. With Starship, we're not doing that. We're just coming straight down. We'll hit terminal velocity, which with Starship is around 200 miles an hour, and then we use a flip maneuver to ignite those engines, do a landing burn, and then touch down on the ground. So you don't need a runway. We're doing that, again, designed because when we go to the moon, when we go to Mars, there's not going to be a runway there for us, and so that propulsive landing is going to be really important. This is an animation of pretty much what we were just watching on actual Starship video, which is pretty incredible. But we go through peak heating. One of the benefits of today's trajectory, actually, we got closer to what the heating profile will be on just a normal mission when you compare it to our previous flights, which were headed out to Hawaii. So we go through peak heating, and then we hit subsonic, and then Starship splashes down in the ocean. Again, we're not doing a landing burn on this flight, and we're not expecting Starship to survive the impact. We're not going to be recovering any of the hardware. For now, though, we are just still waiting to see if we're going to get some signal back. We're currently at a loss of signal with Starship. Don't know for sure what its status is, and so we're just continuing to listen in. But it was pretty incredible seeing the flaps really do their thing to maneuver the vehicle as it's moving through hypersonic. One of the big trade-offs between something like Shuttle and Starship is wings can be pretty heavy. And so if we can really demonstrate that Starship's controllable through that hypersonic regime when you're coming through the atmosphere, 25 times the speed of sound, you can save a whole lot of weight by not having really big wings. So super valuable to get this data, super valuable to then figure out what we're going to do on our next test flights.
Yeah, and you'd brought up a really interesting point, too, that for on Shuttle, you are gliding in, going back to a runway. On Starship, because we're landing vertically, we are basically coming down, and then we've seen this during the suborbital campaign. We're not going to see it today, but during the suborbital campaign, we did the flip maneuver and then light our engines for a landing burn. And that's also really important for some of our other terrestrial destinations. That we don't have as much of an atmosphere on Mars. There is pretty much no atmosphere. There's some great views from our previous test campaigns of a landing burn and upright landing. But on the moon, there is no atmosphere. On Mars, the atmosphere is extremely thin, so you actually need some other sophisticated techniques that other landers have used to land there. And so this vertical landing technique is really important to landing on destinations like those, which is ultimately where we're trying to go.
Yeah, absolutely. So we hope to demonstrate that landing in future missions. That wasn't one of our objectives for today. We wanted the ship to focus on opening and closing, the first demonstration of opening and closing the PEZ door, which is where we will deploy Starlink satellites from in the future, as well as a gathering data on how the heat shield tiles performed during the entry period. And so far, all of that has gone really well. So overall, it's been pretty great, and it's great to see how those initial tests that we performed a couple years ago for those high altitude tests allow us to see what those will look like in the future. But this piece that we're doing today of, okay, if we are coming back from orbital velocity and we're going through that entry period, that is the missing piece, right? We already figured out how to land once the ship gets to a certain velocity or altitude, and it's really this piece that we were trying to figure out today. How do we get Starship to survive orbital velocity, atmospheric entry, and we hope to find out soon.
Yeah, I mean, we talked about rapid iteration and how we do design. Part of our philosophy is testing early and often and trying to test in a way that is as flight-like as possible. But there's only so much you can do in a chamber where you're trying to simulate the atmosphere in a laboratory. So there's nothing quite like when the heat shield tile hits the atmosphere in flight to gather that wonderful data and prove out some of the analyses and probably teach us a bunch of things that we didn't quite get right.
For sure. And obviously, for those of you that have been watching along with us, those were incredible views to see of that entry period where we saw the heat generating because of friction as the belly of Starship was making contact with the Earth's atmosphere, and that resulted in some plasma. So as Dan said before, we believe that we're in a bit of a blackout period at the moment. We are expecting the vehicle, if it's still alive, we would be expecting the vehicle to be approaching subsonic or slower than the speed of sound speeds in 3.5 minutes from now. So if it's still up there in one piece, it still has a way to go. We're not there just yet, but we saw that plasma field building up around the can blanket the entire vehicle as it does with all of our Dragon missions. At a loss for telemetry at that point in time.
Yeah.
So
Dan's seen a lot of those with Dragon missions that he's supported.
Yeah, absolutely.
And we are hearing through some of the telemetry that it did look like we lost Starlink and our TDRS data flow at the exact same time. Now, if both of those signals are cutting out at the exact same time, that could mean we lost the ship. It has been several minutes since we've gotten any data from Starship. We are waiting just a couple more minutes just to see if we can get any additional confirmation, but that is one data point that we're tracking, and that could indicate that we had a loss or a breakup of the ship during that reentry. So might not make it all the way to splashdown today, but we were able to get through the early phases of reentry, hit some of that peak heating, which was just really incredible to see a Starship coming back from space after getting all those views from space for the very first time. So we'll just keep on listening in on the loops here, see if we hear anything over the next couple of minutes, and that might bring a close to a pretty successful day so far. So again, we did lose the TDRS. That's the tracking and data relay satellite. That's the satellite system that pretty much every spacecraft operating in orbit right now will use to get data. We were able to get some signal through that, and then we were also getting data back through Starlink.
Live view here of mission control down at Starbase. So these are all the folks who are experts on the various different systems, taking a look at the live data that we did have. Probably in mission mode still, but
absolutely.
It would be so tough to stay focused with what an exciting day we've had today.
Yeah, to quote Monty Python, I'm not dead yet. We don't know, as Dan said. We did lose connection with TDRS, which is the tracking and data relay satellite system and Starlink at the same time. So it is a realistic possibility that we lost Starship, which honestly was always on the table. We didn't know how far it was going to get. The further we could fly and the more data we could collect was always the biggest win. And so regardless of, if we did lose the vehicle and we are not able to, make it all the way to our intended splashdown, note that we weren't intending to recover this vehicle, either vehicle, the Super Heavy booster nor the Starship. We weren't intending to recover either of them. They were both going to basically hit at terminal velocity and break up upon contact with the surface of the ocean. So we're standing by to hear whether or not we are going to be able to get telemetry readings back, but we are possibly anticipating news that we lost Starship due to basically a double blackout from TDRS and Starship data at the same time.
But it's worth mentioning, this is the first time that we have come back at these speeds
Absolutely.
in any of the test flights that we've done so far with Starship. So we are trying to prove out that the heat shield works as intended, that the controllability at those hypersonic speeds works as intended. So if we were able to get back any data on that, that means the next version, what happens on flight 4, 5, 6, is going to be better.
We must be able to get some because we saw incredibly gorgeous high definition views of that entry period whenever it was initially starting. So we must have gotten some data
today
there.
has been otherwise a phenomenal day.
Incredible.
Liftoff on time, full ignition of all of the boosters, engines, successful hot staging, and then ship took it from there.
Yeah, absolutely. We were able to see the ship actually make it further as well as the booster. We were hoping that the booster would perform a soft water landing, but we lost it during just before it was able to ignite the landing burn. But the ship continued on. We saw all six Raptor engines on the ship ignite and then shut down for second engine cutoff. And we saw some amazing views as well, and it's just been certainly a day that I will be taking many screenshots and using them as my computer desktop background for, well, until the next Starship launch.
When we get even better views, I'm sure.
Exactly.
And we also hit a number of our other ambitious test objectives. We had a chance to at least initiate the commands for a propellant transfer demo within the vehicle. This is something that Starship's going to have to do in the future, and these sort of transfers haven't been done at this scale before, so that's a first as well. We also were able to demonstrate that the payload door functions.
And we got to see that,
Yeah, and so those commands were sent. Again, data review to come and make sure that everything performed as expected, but that's going to be critical to deploying payloads in the future once Starship becomes operational. So a number of test objectives hit, much more accomplished than Flight 2, and making steady progress towards a fully, rapidly reusable, reliable Starship.
Absolutely.
And hey, Kate, and hey, Shiva, we were just hearing on the loops, we are making the call now that we have lost Ship 28. So as we were possibly expecting, we lost the data a couple of minutes ago. We haven't heard from the ship up until this point, and so the team has made the call that ship has been lost. So no splashdown today, but again, just it's incredible to see how much further we got this time around. We had a couple of those ambitious objectives that you guys were just walking through that we're able to take advantage of while Starship was in outer space flying over our planet for the very first time. So that was just really incredible. Obviously, there's a lot to go through. Everyone always wants to know right off the bat what happened. Takes us a little bit of time, but I can assure you as soon as we start finding things out, we're going to let everybody know. And I know everybody's going to be excited for the next one. I mean, as I pointed out in the beginning, there's 4 super heavy boosters either fully stacked or getting stacked right behind me. We've got other ships ready to go as well. So it's going to be a really busy time down here at Starbase as we look to really fly Starship as much as possible, get this vehicle ready to go for all the important things it's got to go do.
And with that, we got to say a huge congratulations to our teammates and everyone who's supported the Starship program. There's been flames and reds along the way, but third time's the charm, and we made it to space. We also a big thanks to all of our future customers for your support. And we want to give a big thanks to the people of Cameron County, Texas, for their support, as well as the Coast Guard and the Federal Aviation Administration.
Be sure to follow the SpaceX account on X for more updates from today's test flight and future Starship tests. But before we go, we want to wish SpaceX a very happy birthday. The company was founded on this day in 2002 when it basically consisted of this small team, a carpet and a mariachi band. I don't know about you, but we're feeling 22. Also, it's Pi Day.
Yeah, but I mean, Pi Day is constant and never ending, so shouldn't every day be Pi Day from now on?
I mean, that's a really good point, and I think after a test like today's, we all deserve some pie.
Thanks for watching, and we'll see you next time.
All right, folks, with that, we're going to cut the stream for the day. We've got a successful test overall, probably 90% at this point. We did lose the ship at the end prior to relight, but everything to that point looked great. All the milestones were hit. So at this point in time, we will call that a success and get ready for the next test. We'll get Booster 29 ready and get that in the air. So we'll say good afternoon for now. And we'll catch you this evening for the next launch out of Kennedy. That's going to be a Starlink launch. And we're going to carry that just after 7 p.m. this evening, more than likely. So, again, thank you to my subscribers. Any new subscribers, we'd love to have you a member of the family. If you can take a look around, hit the subscribe button, ring that bell so you get notified in the future of any future live streams or any videos we put up. And thanks again to SpaceX, as usual, for the great coverage and for allowing us to share this event, which was an amazing day. Test 3, a resounding success. All right, folks, thanks again. We'll see you later on this afternoon. Have a good rest of the afternoon.